Quarter 4, Quiz 1 Review, Sections 7.1 to 7.3, Extra Practice Solutions. Alright, so these are solutions to extra practice problems for your quiz for 7.1 to 7.3. Majority of these questions are just going over your rules, so that way you have that reiteration to if you see these questions on your quiz. So if we look at the first set of examples 1 through 4, we're expressing these logarithmic equations as exponential form equation. So if we look at example 1, we have log 2 of 32 is equal to 5. So we want that base to be that whole number, and then that 32 and that 5 are going to work clockwise and switch places. So it's going to be 2 to the 5th power is equal to 32. For number 2, we have log 3 of 9 is equal to 2. So again, that 3 is going to become the whole number, and the 9 and 2 are going to work clockwise to give you 3 squared is equal to 9. For 3, you have log 7 of the square root of 7 is equal to 1/2. So again, the base of your 7 becomes your whole number, the square root of 7 and that 1/2 are going to work clockwise to switch places, and it's going to be 7 to the 1/2 power is equal to the square root of 7. For 4, we have log 3 of 1 over 81 is equal to negative 4. So again, this 3 is our base. It's going to become our whole number, and that 1 over 81 and that negative 4 are going to switch places to be 3 to the negative 4th power is equal to 1 over 81. For questions 5 through 8, it tells us to express these exponential equations in logarithmic form. So your whole idea for like number 5, your base is that whole number that you start with, so that's that 4. That's going to become your subscript, and then the 64 is going to work counterclockwise with the exponent of the 3 to give you log 4 of 64 is equal to 3. So 4 to what power is 64? 3. For 6, we have 9 to the power of 3 over 2 is equal to 27. So this 9 becomes our base on our log. So log 9 of what 27 is equal to 3 over 2. So again, you're working counterclockwise with the exponent and the whole number that's your answer. Oops. For 7, we have 10 to the power of negative 2 is equal to 0.01. So that 10 is going to be our base. So log 10, that negative 2 and that 0.01 are going to switch places. So this is going to give you log 10 of 0.01 is equal to negative 2. You can also write this as just log 0.01 is equal to negative 2. Both of these are acceptable because when you do not write the base of the log, it's understood that it is 10. For 8, we have 16 to the power of negative 3/4 is equal to 1/8. So again, that 16 is our base. We're going to have log 16 of what number? What's your answer? The 1/8 is equal to, what's your new answer? The exponent of the negative 3/4. So log 16 of 1/8 is equal to negative 3/4. For your first set 9 through 12, it tells us to just simplify these. So for 9, it gives us log 6 of 36. So this is asking us 6 to what power is 36? That's just 2. So 2 is our solution for this one. For 10, we have log 2 of 16. So 2 to what power is 16? If you don't know this off the top of your head, the number that you have is that 2, so divide your answer by the 2. So 16 divided by 2 is 8, and then keep dividing that by 2. You get 4, divide that by 2, you get 2. So then count up the number of 2's that you have. 1, 2, 3, 4. That would be 2 to the 4th power is 16. So 4 is our solution for this one. For 11, we have log 10 of 100. So 10 to what power is 100? How many zeros does the 100 have? 2. So that's 10 to the 2nd power. So 2 is our answer. And for 12, we have log 3 of 1/9. So 3 to what power is 1/9? Well, we know 3 to the negative 1st is 1 over 3. So this to what power is 1/9? 3 to the 2nd power is 9. So that's going to be a negative 2. the negative turns the 3 into 1 over 3, and then if we raise that to the second power, it gives us 9, so that's 1 over 9. For our next set of problems, 9 through 16, it tells us to express as a logarithm of a single number or expression. With these, you want to focus on your rules of your properties of logarithms. So if it's addition, you're multiplying your two numbers. If it's subtraction, you're dividing those two numbers. If your bases on the logs are the same. Remember, if you have a number in front of a log, it was originally the exponent on the whole number, so it needs to be moved back to the exponent there. Okay, so if we look at 9, we have, log a of 3 plus log a of 4. We have the same basis here that log a, and we are adding, so we are going to multiply the 3 and the 4. So this is going to give us log a of 3 times 4, which is just log a of 12. For 10, we have log a of 7 minus log a of 5. So again, same bases, but we're subtracting now, so we're going to divide the 7 and the 5. So this is going to be log a of 7 divided by 5. Now you're not going to be using a calculator on your quiz, so you can literally leave this right in fraction form. So it's going to just be log a of 7 over 5. For 11, we have 4 times log a of 2. So this 4 was originally the exponent on the 2, so it's going to go back on that 2. So it's just going to be log a of 2 to the 4th power. With these, you're pretty much working backwards just to reiterate your rules for these properties with these logarithms. For 12, you have 2 log a of 9. So again, that 2 was the exponent on the 9. So this is log a of 9 to the 2nd power. For 13, we have 1/2 log a of 36. So this 1/2 is going to become the exponent on the 36. So we have log a of 36 to the power of 1/2. We can also rewrite this as log a of the square root of 36, same thing. So log a of the square root of 36, that's fine as well. With any of these, yes, you can simplify that term. So like with the log a of 2 to the 4th power, 2 to the 4th power is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So you could have also written this one as log a of 16. And then with 12, log a of 9 to the 2nd power is log a of 81. So again, same thing. For 14, you have a negative log a of 1/6. The negative is a negative 1. So this is log a of 1/6 to the power of negative 1. Now, you're not supposed to end with negative exponents, so technically this would be wrong. So you have to simplify that negative exponent and take the reciprocal of that 1/6 in order to get log a of 6. For 15, we have multiple steps here, or operations. So we have addition and addition. So we remember when we are adding these, we are multiplying those whole numbers as long as our bases are the same. So we have log b of 3 plus log b of 5 plus log b of 2. So same bases, we're going to multiply the 3 and the 5. So log a of 3 times 5 plus log a of 2. The 3 times 5 is 15, so this is going to give us log a of 15 plus log a of 2. We have addition here once more. Our bases are the same, so multiply the 15 and the 2. So this is going to give us log a of 15 times 2, which is log a of 30. For 16, we have log b of 6 plus log b of 5 minus log b of 2. So we're going to start with the addition. So So our bases are the same. Multiply the 6 and the 5. So this is going to give us log b of 6 times 5 minus log b of 2. The 6 times 5 is 30. So this is log b of 30 minus log b of 2. We have subtraction. Our bases are the same, so divide the 30 and the 2. So this is going to give us log b of 30 divided by 2. The 30 divided by 2 is 15, so it's just log b of 15.